Now, to use Llama models for prompt engineering, we will first see how we will perform the setup for this Llama so that you can perform your prompt engineering, you can practice prompt engineering for that. So let us go ahead and perform the setup. So in this session, we will start with the prompt engineering practically. So first of all, we need to understand a few things about Llama, okay? So when we talk about Llama 2, the Llama 2 is actually a collection of pre-trained and fine-tuned generative text models. Now, there are multiple models which are ranging from 7 billion to 70 billion different parameters. So you can just imagine how big this is. There are 7 billion to 70 billion parameters present in this model. Okay, so there are multiple models with these many parameters, and these are designed for dialogue use cases. Now, it usually outperforms open source chat models on most of the benchmarks and is on par with popular closed source models in human evaluations for helpfulness and safety. Another thing to note is that all these different models which I'm talking about, these all are free to use. So basically, you can use Llama free of cost without paying anything. But if we compare this with the ChatGPT, OpenAI, or Gemini, they will need some kind of membership, some kind of subscription. So we can't really go with them for this particular session because again, it is not sure if you will be getting or if you will be ready to pay for that. So it's better we'll learn using Llama. And another issue with the OpenAI and Gemini is that you will have to take some pay as you go subscription. Now, these subscriptions allow you to call their APIs or use their models directly. But to actually be able to fine tune them or to be able to perform different modifications in the model itself or to maybe perform tuning on these models is not possible. You will have to use something like Llama, which is freely available, and you can make whatever changes you want to it, tune it further, or maybe apply different processings on these models to make them good to use, right? So that is why we will be using Llama. And although we are using it only for prompt engineering, but there are a lot of different use cases which are present, right? Prompt engineering is just a part of the LLM. It is just teaching you how you use it. But when we talk about actually using and building LLMs, there are a lot of different processes involved to it. And we have explained that extensively in our generative AI course with LLM, where we take care of all these topics of how you can create your own chatbot, how you can actually modify these pre-written models, how you modify all of them, how you build your own model for this chat phase. So yeah, that's what we have done. But now we will focus on prompt engineering. So for this, we have used Llama, and this is the session about doing the setup. So because obviously LLM are huge in size. I just told you that there are 7 billion to 70 billion different parameters which are present, which makes the size of the model very large. So what we will be doing is we need to do the setup. For the setup, these are the standard lines of code which you need to follow. You can just simply copy this from this file itself because there is nothing much to it. Mainly, we are preparing our environment and we are installing Hugging Face Hub. This Hugging Face Hub and Llama CPP Python. So Llama CPP Python will allow us to use the Llama model, and Hugging Face Hub is where these Llama models are present. So we will be picking the model from Hugging Face Hub, and we are installing the Llama CPP Python, and we are installing NumPy, which is compatible with it. After that, we are giving the model base name. So this is the model. This model is present in this particular path in Hugging Face. So if you look up in Hugging Face, you will find this model at this given path. And this is just the base name of the model which we are using. And if you see here, it is Llama 2 model with 13 billion parameters. Okay, you can use any other model, maybe with 7 billion or with 70 billion. It is completely up to you which model you want to use, but for prompt engineering purpose, it is better if you use 13 billion or 7 billion, because it won't make much difference. We just want to understand how we can perform on improvised prompt engineering, right? So once you run this, it will start installing the packages, and after installing the packages you need to import the model, and once the model is there you will have to use HF hub download to download the model, and we have llamas underscore cpp from where we are importing the llama model. Okay, so we can run this also, and then we are using HF hub download to actually download this particular model and the model baseline name from the model path and the model base name. Okay, so this is what we are using, and the model is actually 9.76 GB in size. So it will take some time, but because we are using GPU, so it won't take that much. So if you want, you can do the same setup in your system also, or if you want to use Google Colab, you can use this file directly. Now, once you do the setup, once you download the model itself, you will have to create a object. Okay, so for this we have to set up the GPU details. So we create a Llama object, and in this we provide the model path, the number of threads, the batch size, the number of GPU layers which you will be using, and here you can just run this particular line of code which gives you the number of GPU layers, and then we come to prompt engineering itself. So for this you will have to create a prompt first. Okay, so this is a prompt. A prompt would be a text statement which you want to give to your LLM. Now this thing you would have tried at least once on your ChatGPT or Gemini or Copilot, whichever you're using. And there you could have seen that once you type in some question or whatever you want to ask the LLM, it will actually give you certain response. Okay, so what you type in is actually the prompt. Now this is my prompt, which is write a linear regression in Python, and my prompt template is basically, it will contain, one is the system, basically what the system is suggesting the LLM to be. So this is what the system is telling to the LLM. It is saying you are a helpful, respectful and honest assistant. Always answer as helpfully. Okay, so this is what the system is telling, and the user, uh, whatever I will be putting as a prompt is basically, this is for the assistant, and this is what the prompt would go inside here. So basically this goes here, and then the assistant will answer. So this is our prompt template. So the system will set some sort of rule for my assistant to answer, and the user will give a prompt, and using the system's rule and the user's prompt, the assistant will create an answer. Okay. Now here I have written that you are a helpful, respectful, and honest assistant. I could have written something like you always give answers in formal tone. Or I could say you work in ABC organization, so all the responses should contain ABC organization in context. Something like that. Okay. So you give certain guidelines via the system. Okay. So guidelines are given by system, the question is asked by user, and the assistant is supposed to give the answer. So this is our prompt template. And after that, so this is run. Then we use the Llama object to actually run the prompt and give us the response. Now here are certain things. One, it takes input parameter prompt, which basically suggests what prompt you're giving. Then max token is the number of tokens. So at max, we are saying that at max, the input could be of 3000 tokens. Now this 3000 tokens is entire thing between this. So this entire thing could be of size 3000 tokens. Now these 3000 tokens could be 3000 different words, and these 3000 tokens can also be a split of the word. Okay. So let's say we have a word like swimming. So it could consider the entire word swimming as a token, or based on how it is taking up the tokens, based on how it um, understands the tokens, it may also take swim as one token and ing as another token. So swim could act as one single token also and two tokens also, based on how your model has been trained to understand the tokens. Okay, this is one thing to remember. Second thing to remember is that whenever we are passing any prompt to our assistant, the assistant is actually charging us, right? We are not in all the cases, like in the free versions which you are using in Gemini, or when you're using the free version of OpenAI, ChatGPT, not that one, but the exclusive version, say ChatGPT 4. So in that case, what happens is it charges you based on the query which you're sending. So if you're sending a smaller query, if you're writing that give me a email draft for leave, then it will consider only the number of tokens there and charge you accordingly. Okay. Now, if you are giving a larger number of characters inside it, if you're giving a larger, more detailed problem or a complex problem, right, where you're saying, okay, the entire statement is there that write an email draft for leave, and specify that this is the organization name, this is the reason for the leave. So you're adding the number of tokens. So as you add the number of tokens, the charges would also increase. Okay, so this is how usually the charges are taken up for your prompts. Okay, but don't worry, because most of the time uh, it's better to give more number of tokens, because it will still charge you less than having someone to actually research it and give you the result, right? So if I am asking a person to actually find out these details for me, if I'm asking someone to write a email for me, then how much I'm paying to that person to write an email would obviously be higher than what I will be charged for asking the LLM to write a draft for me. So it's always a good idea. Now getting back to this, so you have written a prompt here, we have the prompt template, then we have the maximum number of tokens, we have the temperature. Again, we have set the temperature to 0.5. Setting the temperature to 0.5 will make sure that we have some randomness in the answers. But if you want to have only the best of the best answer in the output here, then you will have to give temperature as 0. But if you want to have a lot of randomness and something different coming up every time, some variation in the results, then you would pick a higher temperature. Okay. Then top P, repeat penalty, top K. So this is it. We can run this. So this will basically create a response. Now we will see what a response holds. So we will run this again and let's wait for it to give back the response.
So here you can see we have written the prompt. So this prompt is write a linear regression, and in the prompt template we have given system, and the system is telling the LLM that you are helpful, respectful and honest assistant. Then we give the user the prompt and the assistant. Basically the system will tell the assistant to be helpful, respectful and honest. The user will give the prompt, basically the question which we want the assistant to answer, and then we will get the assistant's response. So we pass it through the Llama model. We provide the prompt template, the tokens, penalty, top K and other details, and we get the result in the response. Now if you see here, the response actually consists of this dictionary. This dictionary contains the ID, the object, I'll take it slow, text completion, then the created ID, then the model details, that is the block, Llama 2 13 billion parameters. After that we have the choices. Now choices is basically the multiple responses to it. So there will be multiple responses present here. We have this response. This choices is basically a list. Okay, and in this list we have the first response, that is this text, which is the system is telling. Then we have the details by the user, that is you have to write a linear regression. And then we have the response from the assistant, which is to write a linear regression in Python you can use scikit-learn library and other details. So this is all the code which is present, which is given as the output. Then we have more details. Now after this ends, we have this finish reason, stop. Then we have the usage, that is the prompt token has 39 prompt tokens are there. The completion token took 423 tokens. So the total number of tokens used was 462. This 462 is something which actually decides your cost which you will be paying in case this was actually payable. Basically if it was some subscription, then the total token counts actually decides how much you will be charged. But let us see the response. Now this response, from response we picked the choice from the dictionary and we took the 0th response and we got the text out of it. So this is the result which we are actually focused on, which is the system, then the user and then the assistant. This is from the template which we provided, and then this is the response, the entire thing, the entire code for writing linear regression. Okay, and if you see in the end, it is also writing, it is also giving some comments. This will output the coefficient of the linear regression, this will output the predicted value, this will give you an idea of how well the model is performing and whether it is good a fit for the data or not. So it is giving some comments also. It is not just giving the solution, it is also giving what is doing what is used for what, right? Those kind of details also it is giving. So this is how you actually give prompts, how you actually use the prompts. Okay, now next thing, so this is the part of your prompt engineering. Next thing what we will be doing is we will have a look at the features of the prompt engineering or the LLM. So the LLM is actually stateless in nature, so we will see that.